Today I am going to explain about the concept video on probability and statistics. My topic is probability mass function. So let's begin into it. So probability mass function. Probability mass function is known as probability function or frequency function, which characterize the distribution of discrete random variable. So it characterizes the probability of a discrete random variable. Let x be the discrete random variable of a function. So we assume that x is a discrete random variable of function. Then the mass probability function of a random variable x is given by p of x equal to p of capital X equal to small x for all x belongs to the range of capital X. It is denoted that the probability function should fall in the condition p of x should be greater than or equal to 0. It should be non-negative. So the probability of x should be always positive. There cannot be present any negative probability of x. So and the summation of the all probability of x variable should equal to 1. So when we add the all probability of add the all probability of a sample of a random discrete sample, so we should get the summation equal to 1. So these two conditions must be satisfied for a probability mass function. Here the range x is a countable set and it can be written as x1, x2, x2, x3, so on. This means the random variable x takes the value xi1, xi2, xi3, so on. This can be stated as explanation below. The probability mass function p of x equal to x, f of x equal to f of x, we can write it as f of x also, of a discrete random variable is a function that satisfies the following properties. F of x is greater than 0 if x range or if x lies between the range of x that supports. Summation of x it will be equal to 1 and p of x equal to summation of a of f x. Definition. The probability mass function is defined on the values of r, where it takes all the arguments of real number. It does not belong to the value of x when the argument value is equal to the 0, and when the argument belongs to x, the value of a probability mass function should be positive. The probability mass function is usually component of defining discrete probability distribution, but it differs from probability density function, where it produces distinct outcomes. So the probability mass function has discrete outcomes, whereas a probability density function has different outcomes. This is the reason why probability mass function is used in computer programming and statistical modeling. So these are computer programming and statistical modeling. We can call it as applications of probability mass function. In other words, probability mass function is a function that relates discrete events to the probabilities associated with those events occurring. The word mass indicates the probability that are concentrated on discrete events. So this is the definition of probability mass function. So here is the difference between probability mass function, which is PMF, and probability density function, which is PDF. The solution ranges between the number of discrete random variables. So in probability mass function, the solution ranges between the number of discrete random variables, whereas in probability density function, the solution is a range of continuous random variables. In probability mass function, it uses discrete random variables. In probability density function, it uses continuous random variable. So here are some applications of probability mass function. Probability mass functions plays an important role in statistics. It defines the probability for given discrete random variable. It integrates the variable from the given random number, which is equal to the probability for a random variable. Sorry. It is used to calculate the mean and variance of a discrete distribution. So it is used in binomial and Poisson's distribution to find out the probability value where it uses discrete values. So using binomial distribution and Poisson distribution, which comes under probability mass function, we can find the mean and variance of a mean, variance and standard deviation of some number. So using PMF, probability mass function, we find mean and variance using two different types. And whereas this plays a mean function in statistics. So probabilities, in this mainly we use probability discrete random variables. Okay, so probability mass function of binomial distribution. In this case of binomial distribution, the PMS has in certain applications such as to find the number of successful sale calls, to find the number of defective products in the product run, to finding the number of heads or tails in a coin flipping, calculate the number of male and female employees in a company, finding the vote count for two different candidates in a election. Considering an example that contains 10 multiple choice questions with 4 possible choices for each question, which one is correct answer? To find the probability of getting correct and incorrect, the probability mass function is used. So these are some examples where we use probability mass function using binomial distribution. So now let's see some example where we use probability mass function of Poisson's distribution. Likewise, binomial PMS has its application for Poisson's distribution also, to find the monthly demand for particular product, calculate the hourly number of customers arriving for a bank, finding the hourly number of access to particular web server, finding the number of typos in a book. So let's consider an example which is a example of probability mass function. So here let x be a random variable and p of capital X equal to small x is a PMF given by capital X value which lies from 0, 1, 2, 3, 4, 5, 6 and 7. P of capital X equal to small x value 0k, 2k plus 2k, 3k, k square, 2k square, 7k square and k square. So they asked to determine the value of k and find the probability of p of x less than or equal to 6. Second, p lies between 3 and 3, x is greater than and 3 lesser than 6 or equal to 6. So for this solution is as follows. So we know using the two main properties of probability mass function, the total summation of xi equal to 1. So therefore 0 plus k plus 2k plus 2k plus 3k plus k square plus 2k square plus 7k square plus k equal to 1. So by simplifying this equation, we get k value is equal to 1 by 10 or minus 1. So we have another rule that our probability value should not be negative, it should always be positive. So we will just consider 1 by 10 as a k value. So now substituting k values in the place of p of x in the place of k. Okay, So next they told us to find p greater than or equal to 6, less than or equal to 6. To find that, we can use 1 minus p greater than 6 because it has lesser value compared to others. So 1 minus k square plus k, substituting k values in the place of k. So when we simplify it, we get probability as 83 out of 100. Similarly, the next question is p of 3 which is less than x less than or equal to 6. So whereas p equal to p x equal to 4 plus p x equal to 5 plus p x equal to 6. So adding those, we will get the probability of the following question. So which will be 3k plus k square plus 2k square. By substituting k value, when we simplify it, we get answer. We get an answer as 3 by 10 plus 3 by 100. We can further simplify the answer also. Thank you.